Cool. So, hey everyone, my name's David. I've been in the crypto space for 12 years. I joined crypto because I thought that it was a revolutionary technology and had a lot of potential to change the world. I was also really fascinated by the idea of money without a bank. And I've started, following LLMs for the same reason, because I think they're a fascinating technology with huge potential to change the world. So, like I said, I've prepared kind of four sort of ways that I see LLMs moving forward, moving crypto forward, and crypto moving LLMs forward. So the first one, and I think it's one that we can do today quite successfully, and it's one that we intend to incorporate into our new protocol. So just quick aside, I'm working on a new protocol called Glow. It's a carbon credit protocol on the blockchain, and that's not really important. What is important is that crypto today is often super inaccessible, especially a lot of the advanced knowledge. There aren't that many blog posts that explain crypto and how it works, but there are lots of Discord channels, IRC channels, mailing lists, Telegram channels where users are having high quality discussions. And so what we could do with LLMs is we can scrape all of this data, and we can feed it into an LLM as training data, and then we can produce an LLM that understands these advanced topics and advanced protocols. And especially if they're like recording conference events, reading papers, we can make it a lot easier for users to learn about LLMs. And this slide mentions something called digestion. Especially if you're doing something like Telegram or Discord, there's a lot of garbage and a lot of misinformation, or a lot of people confidently explaining how something works and being wrong. And so you can actually clean this up in an automated way. Once you've done like one pass of training on an LLM, it has a pretty good idea of what's right and what's wrong. And so you can, and like who's an expert and who's not an expert. And so you can go through your individual bits of training data, and you can prompt it with questions like, okay, how accurate is this information? Where are the inaccuracies? Like what are extended questions we should be asking? And then you can actually really significantly improve the quality of the data and reduce the LLM's like propensity to hallucinate. And so, yeah, I would say like the first thing that we should be doing in crypto is using LLMs to make education a lot easier. I think it's a big opportunity, and we're not waiting for new technology. We can do this with like, the 13 billion and 30 billion parameter LLMs that are openly available today. And there are at this point LLMs with commercial licenses. Open commercial entities can use them without paying any license fees. It's fully open source. So the second opportunity, which is like a little bit further in the future and I think a little more challenging, is to use LLMs, like integrate them into wallets as a form of user guidance. And so I'll use Handshake as an example. Some crypto protocols require basic game theory knowledge to execute well. And Handshake has this like auction mechanism where if you want to purchase a domain name, say like for yourself, you have to engage in a game theoretically fair auction. However, it's only a fair auction if you, as the person bidding in the auction, understand enough game theory to bid correctly. There's like a right approach and a wrong approach. And even though it doesn't require that much understanding, it's like, a 60-second explainer and a user can get it. In the wild, my observation has been that somewhere between 80% and 90% of Handshake users actually get the game theory incorrect. And so Handshake is even more vulnerable to like scams and scalping and malicious behavior than the traditional internet, or the traditional way that domains happen. And it's not because the protocol is bad, it's because the users are not using it correctly. And so we can fix this by putting an LLM in the middle and guiding users. And like if they see a bid, it's like, oh, hey, I realized you're trying to buy your own name and you only bid 35 cents. Maybe you should bid like $10 or $15. And the chances are you're only going to end up paying 40 cents, but you really should increase your bid because this is clearly important to you. And so even as someone who understands game theory very well and played the Handshake auction, knowing the game theory, knowing what I was supposed to do, I also bid incorrectly and lost my own name. And that's when I realized, like, wait, this stuff, even though it's in theory, it's very simple. Like in practice, you just forget the way that you're supposed to behave. And so Handshake is not the only example. There are a lot of protocols that have like bidding or auctions or like game theory strategy that you have to know. And if we use LLMs, we can level up the average quality of user interaction, and that will allow us to reach for even more complex protocols that require a lot heavier game theory. So the third kind of opportunity that I see, and this is a lot more in the future, LLMs need to get more sophisticated, and blockchain design needs to get more sophisticated. But decentralized protocols like Bitcoin depend on social consensus. So the major example would be in the event of a 51% attack, the assumption is that the network will hard fork or users will just abandon Bitcoin. And so it becomes very expensive to do a 51% attack on Bitcoin because you have these like ASICs that become useless. But that like defense of saying like, if you attack Bitcoin, Bitcoin will just turn itself to ash. That defense requires users to understand how they're supposed to respond to the attack. And again, the correct action is not always obvious. And as we saw with like UASFs, as we saw with SegWit and some of the like Bitcoin block size wars, there's lots of misinformation. There's lots of ways to mislead users that aren't experts on the situation. And it can be very difficult for a user to figure out the correct thing to do. So what we can do is we can insert LLMs that understand the social dynamics that are required to keep a blockchain stable. And if every full node is paired with an LLM that's making trading decisions or hard fork decisions or et cetera on behalf of the user, we can potentially level up the blockchain design significantly. So today, it's largely considered like a bad idea to have social elements in your blockchain, or to minimize the social elements as much as possible, because you just can't expect users to make the correct decisions. And when push comes to shove, there's going to be, a huge blitzkrieg of misinformation, attackers intentionally trying to guide users to, make the wrong decision and defend the attacker rather than defend the honest network. And LLMs in the middle are potentially a way to resolve this. And then that allows us to make blockchains that lean more heavily on mass social behavior. And again, this is not something we could probably do in the next 2 or 3 years. We need more development on both the LLM side and the blockchain side. But I think it's a very bright potential future, and that there's a lot of opportunity here. The final one is reverse. So my first three were all how LLMs can help crypto. This one's how crypto can help LLMs. So for the most part, decentralized training is just very difficult. Training is super expensive and it doesn't scale horizontally well. You need like, $300,000 worth of hardware to participate in a training run. And so that makes it difficult to create crypto protocols that can meaningfully help LLMs on the training side. However, what we can do is we can use crypto to incentivize the creation of synthetic data. And a lot of the latest models, especially in the past month and a half, have all been using prompts to generate synthetic data from GPT-4 or other similar LLMs, and basically refine a small amount of input data that's low quality into a large amount of training data that is high quality. And this sort of process can actually be done on, like, say, a $1,000 GPU. So it's a lot more accessible for people at home. It scales horizontally. You can refine 1 million pieces of training data across 1 million different GPUs, and those GPUs don't have bandwidth overheads the way that they would for decentralized training. And so I see a future where you could use crypto to help create large open source synthetic data sets that make LLMs considerably smarter. So yeah, that's it. Those are like the 4 ideas that I wanted to bring to the talk today, and I'm happy to open the floor for questions.
Cool. So thank you for that. That's really interesting. I especially like the idea of having someone to talk to in the form of an LLM as you're going through a potentially difficult process, or maybe you're about to do something that's counterintuitive, which, frequently we get through these flows and there's one thing that's a little bit different about this one, but we get into that automatic clicking behavior and we end up like maybe authorizing something that we don't want to, or doing the exact opposite of what we intended. So I like the idea of like, I think a chat model is quite natural for that. We can answer that. Something I was wondering along those lines is when you were training, if you were to train an LLM for these different use cases, how do you think it might be different for one versus another? Would they have similar training to guide someone through those, or how specific would they need to be? And what do you think the process for providing the good answers to the model before you let it go live?
Yeah, so I think that in general, LLMs just benefit from having more high quality data. So as you increase the footprint, um, any project that's creating good training data for LLMs, you can just take all of that and put it all into one like crypto LLM, or even get it into like the main open source foundational models. And so these models will become useful out of the box. The one exception to that would be if you want the computation to be super cheap. So say you want an LLM running locally on a user's phone, you may want to pare it down from like a 30 billion parameter model, which is pretty smart, to a 1.3 billion parameter model, which has to be, they can be smart, but they have to be very narrowly focused. And so that's sort of where you might have like a blockchain specific one where like this model was only trained on handshake data. It knows almost nothing about anything besides handshake, but because we've made it so specific, it can be super small, and we can put it on a mobile phone or a mobile wallet and run it locally.
That's great. Yeah, I love the idea of them running locally on your phones. Super cool. So we have a viewer question. Sandeep asks, David, what do you think might be the negative externalities of amplifying synthetic data creation?
Yeah, so I think that a lot of the concerns around synthetic data are totally overblown. Basically, we've seen time and time again that, especially over the past 3 months, that synthetic data tends to be considerably higher quality than human data, even when you're going around the like same topic or idea. Humans are lazy, and LLMs can be trained not to be lazy, and so every single answer is super high quality and thorough. And I genuinely believe that LLMs are capable of like high order reasoning and logic. And if you give it a prompt, and you can see this, if you give it a prompt and you ask it like, does this contain inaccuracies, can you fix them? Like we're trying to make training data for another LLM, can you make the highest quality training data possible? It will respond, and it will create high quality training data for you. And so I actually think that the fear that if we build the entire world on synthetic data, you kind of go in these weird directions, and like crappy data builds on crappy data, and you just get nonsense. I don't think that happens. I think the LLMs are smart enough to realize if they're building crap on crap, and then to stop and to fix it. And yeah, so I actually think synthetic data is like going to be the entire future.
Along those lines, Peter has a similar kind of question that you're sort of touching on. How do we establish accountability of LLMs so it doesn't end up tricking the user through a hallucination or lie?
Yeah, so I mean, you have to remember that any human interacting with any other human is also going to be dealing with lies and hallucinations, and a lot of times with humans, it's like totally unintentional. For example, I'll use Monero. Monero is one where people will talk confidently about the properties of the system or the way that it works, and they'll be very incorrect. And if an LLM was doing that, we would call it a hallucination and be very frustrated. But since humans are doing that, we just call them dumb. But the thing is that they're not dumb; they're just misinformed. And I think LLMs again tend to outperform humans, and so as long as the users are aware that the LLMs are capable of hallucinating, I think that a well-trained LLM will hallucinate, quote unquote, less than an equivalent human would, and that you just have to accept that that's a limitation. But the smarter the LLM is, the less it's going to come up.
Yeah, that makes a lot of sense to me. That concept was a big unlock for me when I realized just how much incorrect information I deal with from my interpretation and humans. Like the problem is not the source of the information. It's a problem with information itself. Cool. So thank you very much, David. That was really interesting. I'm going to switch over to our next speaker right now, but thanks a lot.